Hi, today we'll start the life table approach or life tables approach to actuarial mathematics. Remember in previous set of sessions, we looked at functions that can describe the remaining lifetime. What we will do now is to use life tables. So life table, it actually traces a cohort of individuals and see who lives, who dies, and then every time it's recorded the people who live or die. We'll take a few examples and we'll illustrate this. This is very commonly used in practice, and many times those life tables are used rather historical period that you trace a cohort and then you make assumptions adjust for it, or many times it follows a probability distribution that can be theoretical probability distribution to generate those values. So, but in general here, what you trace like the individual at the age of the individual. We'll take a simplified example of the life table approach. So we'll take the individual's age 0, 1, 2, 3, 4, so on and so forth, right? And then you record you trace a cohort of individuals. Let's trace a cohort of 1000. And in actuarial terms, this cohort, we call it LX, right? LX. And X, as always, is the age. So for the first entry here, this will be L0, right? Is 1000. So L0 is the cohort that we started tracing. Obviously that people die or exit this cohort. So let's assume just like those numbers, just for assumption, that in between year 0 and year 1, 20 death, or the cohort, the remaining people of this cohort is 980. And this 980, it will be, instead of LX, it will be L1, right? So on and so forth. So if you want to take maybe a few entries just, and then we'll take a few examples. Let's just like have numbers just to trace them. In 70, you can think 958. Just I'm making up numbers here. It's not really realistic. But this is, again, we'll look at the standard or illustrative life tables that we will use, or usually in actuarial exams that you will use them. And many life tables can be found in any textbook that you look in actuarial mathematics. So let's stay at year 5. You will have people that die again, 942, right? And so on and so forth. Obviously, number of people will die. It cannot increase, right? Because survival function is always decreasing. It cannot increase. It might stay constant, it might stay steady, but it will not decrease. So LX is the cohort that we trace. So L at age 0, 1, 2, 3, 4. What you can also notice in actuarial mathematics notation, there is something called dx. Dx is simply death. So let's illustrate this one here. Maybe it's easier. You have 0, 1, 2, 3, 4. We started with 1000, LX. Here 1000. L at time 0. L at time 1, we said it will be 980. L at time 2, we said it will be 970. And at time 3, we said it will be 958, 942. So this is your L of X, right? So D of X is, you take this period, and this will be D0 equal, subtract 980 from 1000, it will be 20, right? And this will be again 20. So simply, right? So the death at in the first year, 0 year, so it will be, like if you would write it, it will be it will be LX L0 minus L1, right? And you can continue counting, right? You can continue following the D. Here it will be 10, here it will be 12, and here it will be 16, right? So this will be 16, right? So you can write it 10, 12, 16. Right. If you just, maybe I should, like, if you have lines here, just to make sure that I'm not mixing up things. For just not to think this is L, this is number, so it will be as I said, this will be 20, this is 10, this will be 12, this will be 16. This is number, not L, right? And this can be D1, D2, D3, right? It's simple. So D, like if we summarize it, dx will be Lx plus 1 minus Lx, right? So the cohort that at the end of the period minus at the beginning of the period gives you the depth for that period, right? It's simple. But we're gonna develop this notation further. Let's look at what we mean by how Lx now instead of x. So you remember that we said the survival function, or sometimes we give it the notation xp0. What we can, if you multiply both, if you multiply both sides by L0, then this you can think of it, it will be Lx equal L0 Sx. So you can have the survival function here and you can trace it, or in other words you can, which is more, we can think about it this way, take Lx over L0, it gives you S of x. The survival function you take the at the end over at the beginning of the period, it gives you the survival function. And the f of x, and this is, remember, this is P0, right, of x, this x q0, this can be 1 minus xp0, which is 1 minus Lx over L0. But you can also think about it as L0 minus Lx divided by L0. Right? All of these you need to memorize all of them. Right? They are simple. There is nothing difficult about them, right? Let's take a few examples here. Let's take a few examples and then we can illustrate this. Let's take S2. And we're looking at S2 based on this, based on the example we started. S2, or can be written also P02. So P at A0 surviving for 2 years. So at A0 surviving 2 years, right? So we need to look at surviving this for 2 years. And this is, you take L0 and L2. So this will be L2 over L0, right? So the number of people who survived to L2, you divide it by L0. And L0, I can remember, it's 1000. Let me look back at L2. What was it? L2 was 970. Right? Makes sense? So this will be 97%. So S2 or 2P0. If you want TQ0, it's the same thing, 1 minus 0.97, it will be 3%. Right? Simple. Let's take, I mean, you can also think about it, TQ0. If this is your 0, 1, 2, you look at this one here. And this one, you put it in the denominator, L0. And then you look at this minus this. So it will be L2 minus L0. If you do it, it will give you the same. And remember what is L2 minus L0? This is D0 plus D1 over L0. And D0 plus D1, it can be 2DL0. 2D0 over L0, which is you add the depth for the first two periods, which we have 20 plus 10 is 30. 20 plus 10, which is 30 over L0, which is 1000. All of them, they should give you the same answer, right? All of them, they should give you the very same answer, correct? So it's nothing really difficult here. But let's generalize this relationship. Instead of S of x, let's say we want TPX. Remember what's TPX is the remaining lifetime, right? TPX is the remaining lifetime. It's not at time 0, it's at any different age. TPX, if you generalize it, let me write it in blue. TPX, if you generalize it, not at age 0, it will be L x plus T divided by Lx. Right? If you visualize it here, just let me visualize it for us to see it. So this is now, instead of age x, this is age, instead of age 0 now, this is age x, small x. Wanted to see the probability to survive t years from age x. So the age, if you add t years, it becomes x plus t, right? So you wanted to see the survival of here. So you look at your cohort, how many people you started the period here, right? And then you see how many of them survive here. So then the ones they survived over the initial cohort, it gives you the what you are looking for, right? Simple. And similarly, you can think of TQX now is equal to, let's visualize it. Now this is x. We want t, within t years from age x, how many people died, not survived, right? So this is Lx plus t. So what we need here is the death here, right? And this, you can think about it T.dx, right? Number of death, sorry, T.dx, I meant T.dx, right? Number of death. So you can write it T.dx over Lx, because we are looking at here how many people they died on that specific period, right? So everything here needs to be memorized, right? Not much, actually, not much. But what TQX can be also written, which usually I remember this one more, is I always look at what year we evaluating, so this will be the denominator. So we are looking at Lx, not L0 now, because this is x, right? And then how many, like the death over this period. So you start with here, Lx, you subtract from it Lx plus t, it gives you what you are looking for. And obviously TQX, this we understand is 1 minus TPX, because they are complement to each other, right? So all of these needs to be memorized. Let's take example based on our, let me go back here. So we, instead of keeping scrolling down, let's look at this, our example here. Let's take a few examples here. Let's take TP1. Like, let's look at let's do 2P1. Right? It's not P0 here, we're looking at 2P1. Let's visualize it. I like to visualize it. So we are at 1, not at 0, at 1. And we wanted to add 2 years. So if T is 2 years, so it will be 2, 3, right? Because this is your T. Sorry. This is your T, right? So we wanted to see the survival function of this. So this one, you need to see survival. P is surviving, right? Surviving 2 years, right? From age 1. So TP1, by definition, what we looked at, or, you know, by logic as well, is you look at the cohort who survives to age 3, right? L, L for the cohort who survived to age 3. You divide it by the cohort we started at this period, because we're evaluating at 1, right? We're evaluating at time 1. So who started at period 1, and then who survived, and that will give us the probability, survival probability. We go back to here because we need to look at 1 and 3. So we need to look at 1 is 980. So we started 980 here. And by time 3, we have 958. 958, right? So 2p1, it will be 958 divided by 980. If you use the calculator, 958 divided by 980, I got 0.97755, right? So this is the probability of surviving 2 years from age 1. Based on what? Based on not theoretical equation, but rather based on a cohort of individuals, assuming that assuming that this, we're looking at the probability of an individual of this cohort that is selected at random. What's the probability for that individual to survive to age 2, right? So this is straightforward, not really difficult, right? So let's take another, the opposite of 2p1. Let's look at tq1. I mean, you can right away do it 1 minus 2p1 right away. 1 minus 0.9775, it should give you 0. Right away you can do this, right? But just to also try different ways, 2q1, I would always, whatever here, this is the age you're evaluating at. Or let's visualize it first. We need to start from age 2, 3. So it's not survival, this is death occurring between 2 years, and the year of evaluation we're starting here. So because the year of evaluation we start here, it will go L1, and we need the death here. So you look at those who what we started the period with, the cohort we started the period with, and you subtract those who survived to 3. So then it tells you that this is the death, which is exactly gives us the mortality rate. So L1, which is, I have it written here, right? 980. Minus L3, which is 958, divided by 980. If you do the same thing, you should get the same percentage. Let's do it again. 980, 958, 22. So death is 22 divided by 980, which should give you exactly the same percentage, right? Should give you exactly the same percentage. I got a little bit different the number. I think it's because of a rounding error. Just let me double check. At year 2 we started with 985. Yeah, it should be 22 divided by 980. $22 divided by 980. Very good. Okay, so it's straightforward, simple. There is nothing really difficult at this stage, but let's add a little bit of complexity here, right? Not to make it complex, but just to look at another example here. Let's look at, remember our friend, we looked at this one, mqx, and what we said, this is the deferred period. and this is like the age, of course, always age x, and this is of course like the death. So if you visualize this one, it will be you are at age x, right? You're evaluating at age x, and you add to the age x, you add x plus n, and then you add x plus n plus m. This is, we did it last time, and by now you should have done also the practice questions that I gave you, and that should help you. So you are here. So we need the death here, the probability of dying here for somebody selected at random here. Right? For somebody selected at age x at random at age 6, what's the probability for that individual to die between the age x plus n and x plus nm, right? We did this one. Let's take example based on the table we looked at. Based on the table we looked at, let's take maybe 2 q1, right? Let's look at 2 q1. Remember, if there is no one here, m assumed to be 1. Right, so this one is equal to 2, 1, q1, right? So if you visualize it here, you would have, the year of evaluation is year 1. You add to it your n, which is 2 years, so it becomes a 3. And then the death occurs the year after, right? The death occurs the year after, so it will be 4. So 2 q1, we are here. So the simple way is, as always, the year of evaluation, the year we look at is 1. So the simplest way to do it is L1, right? This is the simplest way. The year of evaluation, where you get it? We get it here. But the death here is, we need those who were at the beginning of the period minus like the L4, right? So the death here is, you take the L3 minus L4 gives you the death here, but we need to evaluate it here, right? So L3 minus L4 for this one, we go back to our example, L3 minus L4. L3 958 minus 942. 958 minus 942 divided by L1, right? We need to be careful about what we divide by, and L1 it should be 980, right? Yeah, 980. And this becomes 958 minus 942 divided by 980. It gives me 0.163265, right? But in general, I mean, if you look at this one in general, mqx in general, you would need to, again, what goes at the denominator is lx, right? Then you would have, remember when we visualize this one, you have x plus n plus m, and death happens here. So this one will be L. Now this one, x plus n minus L, x plus n plus m, right? And this is something you need also to memorize, right? It's very important, but it's, again, it's not really hard memorization. It's just conceptually, you need to understand it conceptually. Like, there are other formulas obviously for mqx. We did, like, again, let's visualize it one more time. x plus n plus m, right? So the death here, this is one way, right, to calculate it. We also previously looked at alternative ways that for an individual here, you need to survive first here. So this one will be to survive to x plus n for somebody age x, so npx, right? You survive here, and then death happens, so multiplication, and then death happens in m year, so it will be mpx+n, right? So death happens for m, right, at m year. So, and multiply this with this one. But we looked at also the same logic is, if you are here, is you take here, you want to find the probability. You say, what if I survive here and I subtract from it surviving here? So this can be also npx multiplied, oh sorry, you subtract from it n plus m for px, right? If you, and because both of them, I mean, if you want, you can verify, like all if in terms of lx, just like for this is to also remember it. But if you want to verify it, you just substitute lx and lx plus n and lx plus nm, you know, and then they should get you back to this one, right? All of them. So you can verify, you just play with it and see if you can get the same result, right? And this is I mean, we looked here n m q x, right? That's for this one. But I will, yeah, I mean, I think let me finish here and then we'll come back to another topic in next session.